So we're going to do this question here, which is 233 times 3.4567 plus 67 times 3.4567. Now, what do you think we'll do with that one?
Well, the two numbers you're multiplying by, they're the same. And so if you add these numbers together and times it by only one of these, the answer would still come out the same.
Now, why does that work?
Because if you have 3 times 10 plus 6 times 10, 3 times 10 is 30 and 6 times 10 is 60, and so that would equal 90. But 3 plus 6 is 9, and 9 times 10 is 90.
Oh, so you've got a really good example there. Do you think it always works?
Okay. I think so. The last number has to be the same though.
All right, so if I go and draw this, all right, if I say that in your case, you have 3 times 10, and we're going to draw it as an area.
Mm-hmm.
And you have 6 times 10. Yeah?
Mm-hmm.
Then how might you use the area model to see what we're talking about?
Well, if it's the area model, then there would be a 0 here.
Oh, I see. Okay, so actually you're thinking of the 10 as being 1, 10, and 0 units, 0 ones.
Yes.
Okay.
And so that'd be like this.
Mm-hmm.
And so 3 times 10 is 30, and 0 times 3 is 0.
Mm-hmm.
And 6 times 10 is 60, and 0 times 6 is 0.
Okay. What if we look at these guys? Do you think these two rectangles that we had, do you think it might be convenient to put them together somehow so that we only do one calculation?
Yes, well, if you have this, that might be a little long.
Doesn't matter. I didn't draw them very well either.
That would be e plus 6, and that's a 10.
So up here, this 3 plus 6 is basically 9, right?
Yes.
So does that mean that you can use this idea? It doesn't matter what your numbers are.
Yes. Because this 3 plus 6 thing is like, this is your 3 part, and this is your 6 part.
Okay, so here we've got 3 times 10 and 6 times 10, and altogether it is 9 times 10.
Mm-hmm.
All right, so let's go back to our question. So in this case, let's do an area model for this question at the top here. And we've got 233. So let's draw that across the top here. And this guy is 3.4567. Okay, so this area here represents 233 times 3.4567. Okay, we're going to add this to 67. Oops. Okay, and this is 3.4567. All right,
Yes.
So with our area model like this, what do you think we can do with these two rectangles?
Merge them together.
So we're going to actually sort of push them together, aren't we? All right. So what I'm going to do is actually shuffle this guy over. I'll do him a different color. Okay. So we're going to add him onto here. Okay. 67. And if we sort of think of that as just being 67 times 3.4567, that still makes sense, doesn't it? So we don't need this guy anymore.
Yes.
Okay. So now, what does this area model show us that we're actually trying to figure out? Right, is there an easier way to think about this great long problem at the top here?
Well, now that you have the two sections merged together, you've got to add them together.
Okay.
Like add the timesing number.
Okay, so this length here of our new rectangle, what's that?
233 plus 67.
Oh, okay, let's do that one. All right, so we'll do it here. 233 plus 67. You want to talk me through that one?
So 3 plus 7 is 10.
And carry the 1.
Yep.
Okay.
3 plus 6 is 9, and then you add the 1, and that's 10.
Okay, so carry again.
And 2 plus 1 is 3.
All right, so actually this whole length here is 300.
Yes.
That's nice. That makes it much more convenient, doesn't it?
Yes.
Okay, so now I'm going to take away the content over here. Okay, we don't need this anymore. And we'll go back to our written algorithm, shall we? All right, so we've got 3.4567 times 300. Do you think you can do that for me?
Well, these first two digits in the 300 are both zeros. So if you times a 0 by anything, that would just end up as a 0. So we're going to skip straight to the 3. And so, because we're in the hundreds, you need your two zeros to hold the place.
Okay.
And then, so 7 3s are 21. 6 3s are 18 plus 2 is 20. 5 3s are 15 plus 2 is 17. 4 3s are 12 plus 1 is 13. And 3 times 3 is 9 plus 1 is 10. I didn't line that up correctly.
That's okay.
Yes.
So now what do we do?
Well, your decimal place is here. And so your decimal place would be there.
Now, why did you put it there?
Because it's lined up with the top number.
Oh, I see. So actually, because you've set it out this way, the decimal place is still in the same position as
Yes.
far as the result is concerned. Do you think you can check that? Like, do you think you can do a spot of sense making to say, actually, this makes sense, this answer makes sense? Maybe some estimation.
Yes. Well, if you do 3 times 300 equals 900, that's sort of close to this number. So it also has that 4, 5, and 6, and 7. So that's roughly 3.5. And so 300 times 1.5 is 450. And so 900 plus 450,
Why did you choose 1.5?
because I'm not sure. I think I should have done 0.5.
Okay, do you want to change that?
Yes. So 300 times 0.5 equals 150. No. Yes, 150. And 900 plus 150 equals 1050. And that's quite close to 1037.01.
So now you're reasonably sure you got there?
Yes.
It's looking good. Thank you so much.